Good day to you out there, viewers. Today, we want to have a look at a question on complex number, which relates to circular function. When I say circular function, that means I'm talking about sine, cosine, tangent, and what have you. So this is what we call some circular function of complex numbers. All right, this is the right hand side. This is the left hand side. So we want to prove that what we have on the right is the same thing as what we have on the left and vice versa. So I'm going to start from the right hand side because that is where I have enough information to work with. Now, but the observation I want us to have first is the way the complex number is written in polar form is not the way it is here. You have to recall this, that complex number z in polar form is cosine theta plus or minus I sine theta. I represent the imaginary side. So plus or minus, depending on what the question says. If you look at here, we have minus, we have positive here, we have negative here. So that means where negative is, we put negative. Where positive is, we put positive. Okay, this with a modulus R, but here we can say that modulus R will be 1. Let me put all this one in bracket so that this 1 given here is not the modulus. Take note of that. But there's an invisible one here, and there's an invisible one here. So these two ones here, up and down, are separated from this. So the first step is to rewrite this in the right form of a complex number. Okay, let's go there. How do I now write it? That will now be 1 plus, open bracket, cosine. Okay, before I do that, you need to recall this also, that sine theta, recall again that sine theta is the same thing as cosine of pi over 2 minus theta. And cosine theta is the same thing as sine into bracket pi over 2 minus theta. So this is one of the basic knowledge in trigonometry. Now, I will now use this to replace this. I will use this to replace this, so that the imaginary part will contain sine as it is supposed to be in a complex number, while the real part will contain cosine as it is supposed to be in a complex number. Now, starting from the right hand side, I'll write 1 plus, instead of writing sine theta here, it will be cosine of pi over 2 minus theta. Then plus imaginary, instead of writing cosine theta, it will be sine into bracket pi over 2 minus theta. All over, same will be done here. So let me put this in bracket. Okay, 1 plus, that will be cosine, open bracket, pi over 2 minus theta, minus imaginary, it will now be sine, open bracket, pi over 2 minus theta. Then close the whole thing raised to power what? N, which is this. So this N is this. Okay. Now, remember I said we can write complex form number also in Euler's form. Euler's form is this. which I wrote the other time. That's r e to r positive or negative I theta. So r is the modulus, but our r is 1, as I've already mentioned. So that means I will use positive here, I will use negative for this one. So what do we have? So we now have 1, this one, plus the whole of this now will become e to I into bracket pi over 2 minus theta all over 1 plus e to negative I to bracket pi over 2 minus theta, all in bracket raised to power what? N. So I want to rewrite this one so that this negative will leave here. You are applying what do we call it? Indices. That means I'm going to have 1 plus e to positive I into bracket pi over 2 minus theta all over 1 plus 1 over, this negative has become 1 over, then I will now have e to positive I into bracket pi over 2 minus theta. Bracket close to power n. Okay? So the next thing is to simplify this. How do I simplify that? Alright, to simplify this, let me make this one 1 over 1. So I'm going to find the LCM for this, the old denominator. So it's now going to be 1 plus e to I open bracket pi over 2 minus theta all over, this will now give us e to I open bracket pi over 2 minus theta plus 1 all over e to I open bracket pi over 2 minus theta. Yes, I found the LCM for this one. Now, all raised to power what? N. But to make the work well understood, I'm now going to write the division, the common division line, which is this. This is the common division line. I'm going to write it sideways. That will now be 1 plus e to I open bracket pi over 2 minus theta. Let me put it in the bracket. Divided by, that means this division line, then this one. That will be e to I open bracket pi over 2 minus theta plus 1 all over e to I open bracket pi over 2 minus theta. Bracket close, raised to power what? N. Okay. According to, the whole n is for the whole of them. So that means, so according to basic mathematics, this will change to multiplication, while this one will turn upside down. So I'm going to have 1 plus e to I open bracket pi over 2 minus theta multiply by, then I'm going to have e to I into bracket pi over 2 minus theta over e to I into bracket pi over 2 minus theta plus 1. The whole bracket, then raised to power n. Alright, it's obvious that these and these are the same. Look at this. They are the same. So that means, what do I have left? It's obvious that I'm having only e to I open bracket pi over 2 minus theta, then a bigger bracket raised to power what? N. So according to the law of indices, the power outside can multiply the power inside. So I'm going to use n to multiply I into bracket pi over 2 minus theta. That will now give us e to I n open bracket pi over 2 minus theta, which is the left hand side. So that is the proof. QED. If you really appreciate this, please do not hesitate to like my page and my channel, YouTube channel as well. Share with others. I'm going to bring in another question on complex number in the next video. Thank you for watching.